Hey students, welcome back to my channel. And today we are going to discuss some paper 2 questions from the chapter of chemical calculations. Students sometimes find these questions difficult to solve. So let's see, and I will guide you also that whenever certain thing is required, then how to solve these questions. There are certain formulas and the ratio method which you have to use in the questions. But it's important to note down or to understand that when you have to use which thing. For example, we have this question, 2.58 grams of metal oxide is reduced to 1.92 grams of metal. What is the relative atomic mass of M? Now here, we don't know what is M and they're asking us to find out the relative atomic mass of M. Here, what they have given us, the mass of MO2 means the mass of MO2 is given and the mass of that metal is given. Metal M is given. So probably the reaction will be like this, that MO2 gets reduced to M and O2. Reaction will be like this. And how do we find this relative atomic mass? To find the relative atomic mass, we have just one formula, which is moles is equal to mass over molar mass. Like we have other methods also to find out the relative atomic mass. One of the method is in which the percentage abundances are given to you. Then you will find the relative atomic mass if the percentage abundances are given. Or you can find out the RAM from the periodic table. But here nothing is given. So you can use this formula. Moles is equal to mass over molar mass, which is equal to AR or atomic mass of a substance. Now here the problem is we need to find the molar mass. So we'll take it as X. We have the mass is given in the question, which is 1.92, but we don't have the moles of M. To find the moles of M, there's only one option. We can take the ratio. Because whenever a chemical reaction is given to us, chemical reaction or an equation is given to you, then we can find the substance by taking the ratio with another substance. Like if we want to find out the moles of M, if we need to find out the moles of M, then we can take the ratio from the moles of any other substance with the moles of any other substance. So here the other two substances are MO2 and oxygen. We cannot take the ratio with MO2 because we cannot find the moles of MO2. We just have the mass of MO2. We don't know the molecular mass of MO2, so we don't know the moles and we cannot find it. But we can take the ratio of M with oxygen. For oxygen, we can find out oxygen's number of moles. First of all, we'll find out the mass of oxygen by doing 2.56, which is the mass of MO2 with the mass from the mass of M. So we can do 2.56 minus 1.92, and it gives us 0.64. So the mass of oxygen is 0.64 grams. Now we can find the moles of oxygen by using the same formula, mass over MR, mass over molar mass. The mass of oxygen is 0.64 and the molar mass of oxygen is 32 because oxygen is O2. So we'll do 16 into 2. So it comes out to be 32. So 0.64 divided by 32. 0.64 divided by 32. 0.02. The moles of oxygen are 0.02. Now we can take the ratio between the moles of oxygen and the moles of M. From the equation, there are 1 moles of both of them. So 1 mole of oxygen and 1 mole of M is coming out from the reduction of MO2. 1 mole, so 0.02 will also give 0.02 moles of M. Now we find out the moles of M here. Now substitute these number of moles in this formula. Number of moles of M is equal to mass over molar mass. Number of moles 0.02. Mass is 1.92 divided by AR. So we can find it out by doing 1.92 divided by 0.02. 1.92 divided by 0.02, and the answer is 96, which is B. Option B is correct, 96. So hope you have understood this question. Next question is, the equation for the decomposition of calcium carbonate is shown. This is the equation given. And mostly, whenever any equation is given to us, in most of these questions, we have to take the ratio somewhere in our calculation. What mass of calcium oxide is produced when 10 grams of calcium carbonate is heated? So here also, that's the thing, that one substance mass is given and you need to find the mass of the other substance. The mass of calcium carbonate is given to you, which is 10. And you need to find the mass of calcium oxide, which is not given. So you will take the ratio and find out. How you will take the ratio? Ratio will be between calcium carbonate and calcium oxide. We will always take the ratio as this: given ratio required. Given ratio required means whatever is given to you, 10 grams of calcium carbonate. So calcium carbonate will be first, and then required. Whatever is required, the mass of calcium oxide is required, so it will be after it. So given ratio required, calcium carbonate ratio calcium oxide. Now, first, you will see their grams or their mass from the balanced chemical equation. That in the balanced chemical equation, what is their mass? So calcium carbon, there is 1 mole of calcium carbonate and 1 mole of calcium oxide. So we can find out their masses, their atomic mass of calcium. Calcium carbonate, CaCO3, calcium is 40, carbon is 12, oxygen is 16 into 3. So 16 multiplied by 3, oxygen is 48, plus carbon 12, plus 40, calcium 100. So the mass of calcium carbonate is 100. Let's find out for calcium oxide. Calcium is 40 plus oxygen is 16. 40 plus 16 is 56 grams. So according to balanced chemical equation, 100 grams of calcium carbonate is giving 56 grams of calcium oxide. So 10 grams of calcium carbonate will give how much? It's very easy to take the ratio. Now we'll use the crossover method. 10 multiplied by 56 divide by 100. 10 into 56 divide by 100. .6. So the answer is 5.6 grams, C. Next question is the relative atomic mass question, RAM, which I told you before also, that in some of the relative atomic mass questions, if the percentage abundance is given to you, like in this question, so and for the isotopes, we can find the RAM of a substance by the other method. Mostly to find the RAM, we have the formula: the mass of the isotope, mass of any one isotope multiplied by its percentage abundance, plus the mass of the second isotope multiplied by its percentage abundance, plus so on. If you have three isotopes, 4 isotopes, you will keep on multiplying with them, their mass with their percentage abundance. Then divide the whole by 100 or whatever is the total of the percentage by that thing. Now, here they are saying that the sample of iridium has a relative atomic mass of 192.29. So relative atomic mass is already given to us, which is 192.29. It's already given. The sample contains 2 isotopes only. 64.50% of the sample is 193 what is the other isotope in the sample? So one of the isotope is 193. So we'll write the mass here. 193 multiplied by its percentage abundance is 64.50 plus. Now it has another isotope and we need to find out the mass of the other isotope, that what is it. How we'll do it? We will subtract the total percentage is 100. We will minus 64.50 from 100 and we'll get the percentage abundance of the second isotope. So let's do 100 minus 64.50, 35.5. So the percentage abundance of the other isotope is 35.5. Now we don't know the other isotope's mass, so we'll write here X multiplied by the abundance 35.5%. We'll divide the whole with 100 and then solve it. Here 193 multiplied by 64.5, 12448.5. 12448.5 plus it's 35.5x divided by 100. Now first we'll take this 100 on the other side of the equation, so it will multiply with 192.29 multiplied by 100 is equal to 12448 plus 35.5x, 192.29 multiplied by 100, 19229, 19229. Now we'll take this 12448 over here, this one on the other side. Here it is plus, so on the other side it will minus. 12448 is equal to 35.5x. Now we'll minus it. 19229 minus 12448. 12448, 6781. I'll write here. The answer is 6781. 6781 is equal to 35.5x. Now take this 35.5 on this side. So it will divide because over there it was multiplying with x. We'll divide 6781 divided by 35.5. 35.5. 191.0. The answer is 191.0x. So the value of x is 191 and the answer is C. Iridium 191 is the second isotope. Next question. The equation for the reaction of sodium with water is shown. Again, we have an equation. So maybe we'll take a ratio. What is the volume of hydrogen measured at RTP produced when 18.4 grams of sodium reacts with excess water? So here they're asking us the volume of hydrogen gas, and they have given us the mass of sodium, which is 18.4 grams. So we have to go from the mass of sodium to the volume of hydrogen. And in the middle, we have to find out the moles of both. So first step will be, we will find the moles of sodium, because when we have this situation that one of the amount of one substance is given and we need to find the amount of another substance, like mass is given, we need to find the volume of the other substance, then we have to follow some footbridge steps. The first step will be that from the mass of sodium, we will find the moles of sodium by using the formula. Then from the moles of sodium, we will find the moles of hydrogen gas by taking ratio. From the moles of hydrogen, we will find the volume of hydrogen, again by using the formula. So these are the 3 steps which we have to follow in this type of question. So for the first, we'll find moles is equal to moles of sodium is equal to mass over molar mass. So the mass of sodium is 18.4 divided by the mass of sodium is 32. 18.4 divided by 23, 0.8. So the moles of sodium are 0.8. First step is done. Second step is we will find the moles of hydrogen by taking the ratio. So we'll take the ratio between the moles of sodium and the moles of hydrogen to find the moles of hydrogen. Now, as we can see in the equation, sodium is 2 and hydrogen is just 1. So the ratio here is 2:1. First, always we'll take the ratio from the equation. 2:1, 2 sodium is giving 1 hydrogen. So 0.08 will give how much? So 0.08 divided by 2 will be 0.04 moles of hydrogen. Second step is also done. Now, when we have the moles of hydrogen, we can find the volume of hydrogen by using the formula. Moles is equal to volume over molar volume. Here, the molar volume is in decimeter cube. The answer is in decimeter cube. So we will use 24. Moles of hydrogen 0.04. Volume we have to find divided by molar volume 24. We can take it on this side and multiply with 0.04. So 0.04 multiplied by 24, the answer is 0.96. 0.96. Okay. 0.04 multiplied by, it's 0.8. I wrote one extra 0 here. There shouldn't be any 0. 0.4. So the answer is 9.8 decimeter cube. Don't do this mistake which I made. Don't use an extra 0. Don't put an extra 0 or don't remove a 0. Use the exact value and recheck your answer. So 9.6 decimeter cube, this is the answer. So these are the steps which we will follow. If one substance is given, one substance amount is given, and we need to find the amount of the other substance. The same thing we'll do in this question also. If 100 centimeter cube of lead nitrate of concentration 0.1 mole per decimeter cube is reacted with an excess of sodium chloride, which mass of lead chloride is obtained? So this is lead nitrate, and they have given us the volume and concentration of lead nitrate. The volume of lead nitrate is 100 centimeter cube, and the concentration of lead nitrate is given 0.1 mole per decimeter cube. And after this information is given, and they have asked us to find the mass of this lead chloride. So this is the same type of question in which the amount of one substance is given and we need to find the amount of another substance. So here from lead nitrate, we'll go to lead chloride, and in the middle, we will find the moles of both substances. So again, we'll write the steps that we have from the concentration and volume of lead nitrate, we'll find the moles of lead nitrate. First step, by using formula. Once we find the moles of lead nitrate, we will find the moles of lead chloride. After finding the moles of lead chloride by taking the ratio, we'll find the mass of lead chloride by using the formula. So these are the steps: amount, moles, moles, amount. So let's find the number of moles of lead nitrate first. Moles of lead nitrate is equal to, the formula which we use for the solutions is volume into concentration divided by 1000. So here the volume is 100, concentration is 0.1, we'll divide by 1000 to get the number of moles. 100 multiplied by 0.1 divided by 1000, 0.01. So these are the number of moles of lead nitrate. This is step number 1. After that, we'll do step number 2, in which we find the moles of lead chloride by taking the ratio between the moles of lead nitrate, PbNO3 whole twice, and the moles of lead chloride. Moles is equal to PbCl2. If we see in the equation, there is 1 mole of lead nitrate and 1 mole of lead chloride. So if 1 is giving 1, then 0.01 will also give 0.01. 0.01 moles of lead chloride. After that, in step number 3, from the moles of lead chloride, we can find the mass of lead chloride by using the formula. Moles is equal to mass over molar mass. The number of moles, 0.01. Mass is not given, we need to find. And the molar mass of lead chloride we have to find. So PbCl2, the mass of, atomic mass of lead, let's find out. Atomic mass of lead (207). So 207 plus 35.5 for chlorine multiplied by 2. So we'll do 35.5 multiplied by 2 for chlorine plus 207, 278. 278. So the atomic mass, molecular mass of lead chloride is 278. We'll take it on this side and multiply it with 0.01. And the answer comes out to be 2.78. This one. The answer is C, 2.78. Now, I hope you get these steps, that when you will do these steps and how. Next, we have a different kind of question. This question is also very common. Which sample contains the larger number of molecules? Now, for the larger number of molecules, instead of molecules, if it comes about particles, if they ask you about the atoms, so or the formula unit, then you have to use the same method. As we know that Avogadro's number 0.6.02 into 10 power 23 number of particles, this much number of particles are present in 1 mole of a substance. Now, whatever mass or volume is given to us, we will convert them into number of moles. We'll find the number of moles of each substance of all the options, and then we'll see that whose number of moles are the largest. Obviously, if the largest number of if substances have largest number of moles, greatest number of moles, then its number of molecules should also be more. So for methane, for option A, for all of them, for these first 3, we will use the formula moles is equal to mass over mR, mass over molar mass. And for the D option, we'll use the formula moles is equal to, moles is equal to volume over 24. decimeter cube. So for option A, the number of moles will be mass 16 divided by the MR of CH4. It's 12 plus 1 into 4. 12 plus 4, it's 16. So 16 divided by 16, it's 1. So its number of moles are 1. For part B, for oxygen, the mass is 16 and the molar mass of oxygen is 32. If we do 16 into 2, then 32 is the molar mass. 16 divided by 2, 16 divided by 32, it's 0.5. So its number of moles are 0.5. For C, we'll do 16 divided by phosphorus P4. So phosphorus is 31, its mass is 31 multiplied by 4. Let's do it. 31 multiplied by 4, it's 124. So 124. 16 divided by 124, it is 0.12. Its number of moles are 0.12. And for D, it's 16 divided by 24. I'm sure this is also going to be less. 16 divided by 24, 0.66, 0.667. So if you see, out of all these, the largest number of moles are of 16 grams of methane. So if they have more number of moles, then their Avogadro's number will also be more. Because if we multiply it with 0.5, it will be less. If we multiply it with 0.12, again less. If we multiply the Avogadro's number with 0.66, it will be less. So the most number of moles will be, largest number of molecules will be in 16 grams of methane. The question about percentage yield. Okay. So for the percentage yield, if you need to find the percentage yield, first you will write the formula. Percentage yield formula is actual yield divided by theoretical yield, which is also known as predicted yield, multiplied by 100. This is the formula of percentage yield. Now the question is, this is the equation given to you. Calcium carbonate is decomposing into calcium oxide and carbon dioxide. 225 kilograms of calcium carbonate, the mass of calcium carbonate is given, is heated until there is no further change in mass. The yield of calcium oxide is 85 grams. Okay, so one of the yield of this product is given. Yield is called mass. The mass is given, and whatever mass of the product is given to you in percentage yield question, the mass of the product which is given to you, it is always your actual yield. It is always going to be the numerator. 85 will be your actual yield. We need to find the predicted yield by taking the ratio. We'll find the predicted yield of the same calcium carbonate. Let's take the ratio. If we take the ratio between calcium carbonate and calcium oxide, 225 kilogram of calcium carbonate will give how much calcium oxide? First of all, we have to see that what is their ratio in the equation. In the equation, it's 1 mole of calcium carbonate giving 1 mole of calcium oxide. We just calculated above the mass of calcium oxide. In this question, the mass of calcium oxide is 100 and the mass of calcium carbonate is 100 and calcium oxide is 56 grams. So we'll use the same instead of calculating again. Calcium oxide is 100 grams and calcium carbonate is 56 grams. If we convert them into kg, because here they have given us the actual mass. The actual mass is also given in kgs. So we'll convert this 156 into kgs by dividing by 1000. So 100 divided by 1000 is 0.1 kg, and 56 divided by 1000 is 0.056 kg. So we'll substitute these values here, that if 0.1 kilogram is giving 0.056 kilogram of calcium oxide, then 225 kilogram will give how much? So here we'll use the crossover method again. 225 multiplied by 0.056 divided by 0.1. So it is 225 multiplied by 0.056 divided by 0.1. 126. The answer is 126 kilograms. This is our predicted yield, the one which we find. This is our predicted yield. The actual yield is 85. Okay, now we'll find the percentage. Actual yield is 85 divided by predicted yield is 126 multiplied by 100. So 85 divided by 126 multiplied by 100, 67.4. 67.4%. So our answer is C. That's how you will find the questions about percentage if they come. So always remember that whatever mass of the product is given to you in the question, it will be your actual yield. Predicted yield will be of the same substance, but we need to calculate it. Whether we'll take a simple ratio like this, or we have to use the whole footbridge steps to find out the mass of a substance. So these are different type of questions which we have covered, and there are lots more, but in this video I can cover only these. Now these are the questions for you to solve and write your answers in the comment box, and after writing the answers I will tell you whether they are right or wrong. Take a screenshot. Question number 1 is finding the empirical formula. It's really easy. If you can do it, very good. If you cannot do it, then write in the comment section that you are not able to do the empirical formula questions. So I will make a video on this too. Then question number 2 is also different. Find out how many hydrogen atoms and how many carbon atoms are there in one molecule of ethene. I'll help you a little bit. There are 2 atoms of carbon. So you will multiply the Avogadro's constant. This Na is the symbol of Avogadro's constant. For carbon, you will multiply the Avogadro's constant with 2. And here, as you can see, for the hydrogen, there are 4 hydrogen atoms. So for hydrogen, you will multiply the Avogadro's constant with 4. And then you will get the answer. So solve these questions. And if you like the video, please subscribe. For more videos, click here. And also click the bell icon to get the new videos as soon as possible, because you cannot afford to miss any of the video which I make on paper 2. Thank you for watching. Thank you for your time. Bye-bye.